In occupational psychology research, offices have been typically described as either traditional, sometimes referred to as enclosed or cellular offices, or open plan. Traditional offices tend to house one or two individuals in private rooms enclosed by walls and often containing most of the amenities required for the job. Danielson and Boding, 2008. Open plan offices, meanwhile, are characterized by a lack of interior walls. They tend to be larger and contain greater numbers of workers, with individual workstations arranged within the office in groups. Brennan, 2002. As open plan offices become utilized, importance has been placed in the research field on understanding what impact they have on impacting on employees' well-being and behavior. This essay shall summarize the impact so that it can be considered whether open plan offices are appropriate for use in the modern workplace. Although this essay focuses on the impact of open plan offices on an employee's well-being and behavior, it should be noted that often for organisations it may not be these factors which drive the decision to adopt open plan offices, but instead, the decision-making will be informed by the economic savings that can be made through adopting open plan offices. Indeed, as Vischer in 2005 pointed out, fewer interior walls permit larger floor plans, which can achieve a greater number of employees being accommodated. It is important to consider these factors, as ultimately it is the organisation which will decide upon if they shall use an open plan office or not. There are, however, advantages from open plan offices to the individual's employees, which are argued for in the literature. For example, it has been suggested that offices that facilitate greater communication and interaction, e.g. those that place individuals close to one another and remove physical barriers to communication, as open plan offices frequently do. These allow individuals to share task-relevant information, promote feedback, and create friendship opportunities. Oldman Brass, 1979, leading in turn to increased interpersonal relations, reduced conflict, increased job satisfaction and motivation. Zelzny and Farras, 1987. Furthermore, open plan configurations have been found to affect the pattern of interaction, with less time spent in formal meetings and an increase in informal communication, e.g. more conversations held around the desks. Observed following the introduction. Brennan, 2002. This helps enable workers to work more fluidly and collaboratively together, which will become increasingly important due to the dynamic nature of work. Although there are issues with too much communication being facilitated, particularly if it non-work related, as it may result in workers becoming distracted from their work. However, there is some research to suggest time spent communicating with employees may reduce as a result of open plan offices. Bernstein and Turbin in 2018 used employees from the global headquarters of a Fortune 500 multinational company that were about to undergo a redesign of an entire floor, stripping out the individual cubicles to create a fully open plan workspace. This study found that after the shift to an open plan office, the participants spent 73% less time in face-to-face interaction, while their use of email and instant messenger shot up by 67% and 75%, respectively. A second study involving 100 employees at another Fortune 500 company was similar, but this time the researchers monitored changes to the nature of the interactions between specific pairs of colleagues before the shift to open plan offices and afterwards. There were 1,830 interacting dyads, and of these 643 reduced their amount of face-to-face interaction after the workspace became open plan, compared with just 141 showing more physical interaction. Overall, face-to-face time decreased by about 70% across the participating employees on average, with email use increasing by between 22 and 50%. The real-life setting of this research is a major advantage, but it does of course come to the expense of full experimental control, and it remains a possibility that other factors besides the office design change may explain the results. Researchers did attempt to mitigate this possibility, such as by allowing time for employees to settle into the new office design before resuming data collection. McElroy and Marrow, in 2010, showed that the benefits of an open plan office can extend beyond communication and can help employees' opinions on their organisation's culture. In the study, they compared a treatment and control group, and they found that the office refurbishment, which involved the combined use of brighter decor, new furniture, greater openness, and higher workspace density, yielded positive changes in employees' perceptions of the organisational culture, whereas no such changes were observed in respect to the control group. Employees in the refurbished, more open office reported their organisational culture as being more innovative, less formal, providing more professional control and fostering greater collaboration than their counterparts in the non-refurbished control office. In addition, occupants in the refurbished office were found to report greater co-worker satisfaction and effective organisational commitment. The study did also find, though, that although employees in the refurbished office were more positive regarding the layout of their office, they were significantly more dissatisfied with the amount of personal space and degree of distraction that accompanied the refurbishment. The design of the study means that it is impossible to analyse the individual contribution of each element of the refurbishment to analyse the different elements of an open plan office and what individual contribution they make, meaning it becomes difficult to find a way of keeping the benefits of an open plan design, which the study has identified, but eliminate the costs. This notion of an organisational cultural impact from an open plan office receives further support from Hall and Ford in 1998, who looked at the development of an open plan office in the real-world context of a company called Keltec, who built a new factory. In the redesign, many of the physical barriers between white-collar workers and production teams were removed, and it was found that following this, staff demonstrated greater empathy between each other, and there was greater understanding between the teams, leading to speedier communication between the teams and problems being resolved more quickly. Another positive consequence that has been attributed by Lindberg et al. In 2018 was that open plan offices can lead to increased activity and decreased stress. In the study of 231 office workers in government buildings in the US, those in open plan offices with no partitions between desks clocked up 32% more physical activity than workers in private offices and 20% more than those in cubicles. And those who were more active had 14% lower levels of stress outside the office compared to those who were less active. Although it should be noted that this study was observational only, and factors like location of stairs and lifts could play a part too. There are, however, negative consequences that can be associated with using open plan offices. One being how their behaviour may change as they become distracted. Many studies suggest that working in an open plan office involves more cognitive effort being used in order to concentrate on one's work. This means that less of a focus is likely to be put on work as distraction increases. Indeed, Craig, in a 2010 survey of 38,000 workers in open plan offices, found one of the biggest losses of productive time during the day stemmed from interruption by colleagues. Another negative consequence is noise. Noise is defined as unwanted sound, Barron, 1994, and has often been reported as the greatest issue of dissatisfaction that staff raise when questioned about their open plan work environments, Sutton and Raffaelli, 1987. Indeed, Lenman and Bordas in 2005 described noise as the issue that workers would most like to be able to control. The reduction in walls, screens and acoustic materials, in addition to increased numbers and groups of employees occupying a single space, can give rise to greater noise than one would be experiencing in single or low occupancy offices. Purnam et al. In 2007 found serial recall of digits to be significantly reduced when participants were played background office noise. However, the evidence linking noise and real-world job performance is more variable, suggesting that although it may be the case that open-plan offices have negative noise-related consequences, this factor may have a limited influence on an employee's well-being and behaviour. One key element which open-plan offices do not generally support is privacy. Privacy can be defined as the ability to control incoming stimulation and interpersonal contact and to limit outgoing information. Sundstrom et al., 1982. Privacy is often associated with any key physical feature which allows voluntary isolation from visual and auditory commerce, such as walls and partitions, doors, and distance to colleagues. There is an important distinction to make between visual and acoustic privacy. Acoustic privacy is a concern in open-plan offices and is essentially the same concept as noise, which can come through people talking and phone conversations. Weinman, 1981. Informational content can be distracting, and interruptions as a result of noise can be stress-provoking and may affect task performance even after the noise has terminated. Cohen, 1980. However, there can also be visual problems through visual distractions in the environment and a pressure to maintain appearances in the environment. Devalerli and Benedict in 1992 asked 5 questions to establish the exact nature of enclosure and privacy for a sample of secretaries. It was found that assessed and perceived privacy correlated significantly, as did perceived privacy with overall job satisfaction, and the relationship between privacy and job satisfaction was uniform across the facets of job satisfaction and increased with time. Kim and Deere in 2013 wanted to establish if the occupants' overall opinion of their workspace was more influenced by the positive or the negative aspects about it. To this, they developed a web-based survey tool assessing the building's occupants' satisfaction ratings for various aspects of the workplace. The questionnaire classified the office layouts into 5 categories. 1. Enclosed private office. 2. Enclosed shared office. 3. Cubicles with high partitions. 4. Cubicles with low partitions. And 5. Open office with no partitions. For every single aspect questioned about, the participants responded more favourably to the enclosed private offices. For noise level, they rated offices with low partitions as the worst office space, and visual privacy they rated for open offices to be the worst. For the other 14 aspects, cubicles with high partitions were rated as the worst. This suggests that although employees may not like open-plan offices, it is because they prefer having their own private office, but when the choice is between open-plan and high-partition cubicle offices, they prefer open-plan offices. As it is often the case that in the real-world organisational situations, it is impossible for organisations to satisfy the desires of all employees to have their own private offices, it results in open plan being the best feasible option. As although it might not be the case that open plan is what employees want, it may be a better option for them than the alternatives given the restrictions in terms of cost to the organisation that giving every employee a private office would entail. There was also data on the percentage of the workforce who were dissatisfied. It was generally found that for most aspects of the working environment, dissatisfaction was relatively low, with even the least favourable working conditions having dissatisfaction ratings of below 20%. There were a few differences for some aspects between the workspace with highest percentage dissatisfaction and the ones with lowest mean satisfaction rating, suggesting that there are certain offices which some individuals particularly dislike, even if it is not shared with the mean of the group to the same extent. The general theme of high partition cubicles being unpopular and private enclosed being popular was maintained. The most dissatisfaction came from sound privacy, where both cubicles with high and low partitions had above 50% dissatisfaction. Open plan had roughly 50%. When this is compared to private enclosed, which was below 20% dissatisfaction, there was a real divergence between the office types for this element, which was not observed for many of the other elements. There was also high dissatisfaction for visual privacy for open plan, which was above 1/3. This further suggests that visual privacy is a key issue for open plan offices. Noise level was also a problem for high and low partition cubicles and open plan, an unsurprising finding considering the results for sound privacy. Also, temperature had an above 20% dissatisfaction rating for all office types, suggesting that temperature was just something that a certain percentage of the sample is likely to complain about. This is promising, though, for the validity of the study, as it does suggest that people will complain about something if they want to, even if it is to do with enclosed private offices, as more than 20% were dissatisfied with the temperature there. This suggests that it is less likely that participants would lie just so that they could end up with more favourable offices by maximising the differences between their satisfaction with different office types, in order to give more of a justification for them to be placed in the office type which they desired. In terms of if the advantages outweigh the disadvantages, the positive impact of ease of interaction on overall workspace satisfaction was 0.21, whereas the negative impacts of noise was 0.41, poor sound 0.20, and visual privacy 0.46. This suggests the overall impact was negative. It may be the case that the workers' dissatisfaction with highly partitioned offices may be in some way relevant to the fact that in a partitioned office you can't see where the noise is coming from. So although there may be less noise intrusion than in open plan, workers will perceive themselves as having less capacity to be able to identify the source of noise, and therefore do actions which may eliminate those sources of noise, e.g. telling a colleague to stop speaking so loudly. Therefore, there is more importance placed on controlling the environment as opposed to the environment itself, and its own quality determining satisfaction. This was further corroborated by Lee and Brand in 2005, who hypothesized that perceived levels of control over the physical working environment will be positively related to job satisfaction, group cohesiveness, and satisfaction with the work environment. They found in a study of 228 workers from 5 organisations, suggesting it was a study with real generalisability, that perceived distraction was not associated with perceived performance levels. Increased distraction was associated with increased preference for enclosed work area and negatively related with satisfaction with the working environment. Increased perceived control was associated with increased job satisfaction and group cohesiveness and satisfaction with the work environment. The relationship between increased actual control and increased group cohesiveness was more questionable. With open plan offices, consideration should also be given to how work is changing. For instance, more people are using voice recognition-based systems at work, Perez in 2019. This will surely have an impact on an open plan office environment where the noise from different people using such systems will add to the interference that an individual is facing with their work. There are also individual differences between employees and different natures of jobs. These differences can be important when determining the impact of open plan office design. Mayer and von Hippel in 2005 stated that as many problems with open plan offices derive from stimulation overload, through difficulties avoiding interpersonal contact and maintaining privacy, the ability to deal with excess stimulation is subject to individual differences. Therefore, as inhibitory control is implicated in selective attention, it was predicted that there would be a freeway interaction, i.e. a greatest negative reaction to open plan offices when an individual had low inhibitory ability, high task complexity, and poor perceived privacy. This was confirmed in effect on job satisfaction, but not on performance. Inhibitory ability and stimulus screening was uncorrelated. The poor privacy and high task complexity interacted with high screening to predict negative reactions to open plan offices. This further suggests the importance of being able to have visual cues so that the sense can be made out of sounds and that these visual cues are possible in open plan offices. Open plan offices critically affect levels of privacy. Levels of privacy affect multiple dependent variables. Lack of privacy is a chronic stressor. It's affected and moderated by task demands and role requirements. The importance of privacy points to the role of control. There therefore needs to be more research of control over physical working environments, and individual differences cannot be ignored. It does indeed validate the importance of appraisal and user perspective in design. There are also differences between different kinds of workers. Calapio and Gardner in 1992 found that managers were more satisfied in enclosed offices than their clerical colleagues. Sundstrom et al. In 1982 found that managers who relocated from enclosed to open workspaces reported larger reductions in their privacy than other staff members who experienced reductions in their workspace, e.g. through the use of barriers, screens or cubicles surrounding their desk. In partial support of these findings, O'Neill in 1994 found a weak but significant relationship between job level and environmental satisfaction, although job level has not been found to be significant in all studies, e.g. Ferguson and Wiesman 1986, Oldham et al. 1991. Overall results support the assertion that managers and supervisors respond more negatively to environments that reduce their privacy. The mixed results in this area may partially be explained by the different operationalization of job level, with some studies simply classifying respondents as managerial or not, e.g. O'Neill in 1994. Others using aspects such as job type and number of supervisees, e.g. Ferguson and Wiesman 1986. The effects of task complexity on interactions with office space has also been investigated. Block and Stokes in 1989 demonstrated that individuals performed better on a complex task in a room on their own, while a simple repetitive task was performed better in the presence of others. Furthermore, Studies have found that specific skills influence their relationship between job complexity and reactions to the physical environment. For example, stimulus screening skills, how well an individual is able to screen out unimportant, unwanted aspects of their environment. Mahimbrey in 1977. Has been found to interact with job complexity, with stronger screeners reporting more favourable outcomes than weak screeners in more open or distracting conditions, e.g. Fried in 1990 and Oldham et al. In 1991. However, overall the literature is inconsistent, some field studies not having found significant relationships between task complexity and the work environment, e.g. Sundstrom et al. 1980. Two common factors affecting privacy are limited personal space and excessive unwanted interaction, Chan 1999. Yet individuals can interpret the same situation very different, Kerr and Weber 2003. Various adaptive processes and coping mechanisms can result in different subjective interpretations of the same environment, Chan 1999. According to Hall 1966, individuals have their own personal space, which when violated leads them to feel crowded and uncomfortable. Thus, when infringements on personal space, intrinsic to the open plan design, exceed employees' comfort levels, feelings of crowding and loss of privacy are likely to emerge. These feelings of crowding and loss of privacy then result in the dissatisfaction and negative reactions displayed by employees working in open plan offices, Oldham and Rochford 1983. Moreover, given that perceptions of crowding appear to influence employees' reactions to their work environment, it is conceivable that the reactions of individuals in the same work environment could vary significantly, depending on individual differences in perceptions of crowding and privacy. The phrase user experience is used in several ways in the human-computer interaction literature. One is to denote the design and use of user interfaces, in effect working as a synonym for interaction, usability, or even user-centered design. Such use occurs in early, Smith et al. 1982, and recent, Chulis et al. 2008, human-computer interaction papers. Another is to focus on experience in a more complex sense, Law et al. 2009. The study by Law found varying opinions among practitioners on user experience, with many contesting its relation to usability. ISO in 2008 meanwhile argue that usability criteria can be used to assess aspects of user experience. There are, though, many studies in the field which attempt to understand more about the issues that need to be considered. Vargas Avila and Hornbeck in 2011 reviewed 60 studies and found that the majority of user experience studies involve eliciting a subjective response, an emotional response to the product, enjoyment of the interaction, and aesthetics. A strong likelihood to a positive response to the appearance will influence other ratings such as usability, enjoyment, and emotional responses. It's far more likely to constitute formative evaluation than summative evaluation, and far more likely to raise design issues which can be fixed during the subsequent development of the product. A review by Andre et al. In 1999 found a lack of consistency between findings from 17 usability studies. Thus the question of which methods are best remains open. Another question that can be asked when designing interfaces is to what degree are the users aware? Hasan Zhao in 2010 examined the role of subjectively perceived ergonomic quality, e.g. simplicity, controllability, and hedonic quality, e.g. novelty and originality, of a software system in forming a judgment of appeal. It was asked are 1. Are ergonomic and hedonic quality subjectively different quality aspects that can be independently perceived by the users? And 2. Is the judgment of appeal formed by combining and weighting ergonomic and hedonic quality, and which weights are assigned? The results suggest that both quality aspects can be independently perceived by users. Moreover, they almost equally contributed to the appeal of the tested software prototypes. A simple averaging model implies that both quality aspects will compensate each other. It should also, though, be considered when focusing on user experience that not all individuals are the same, and indeed there can be group-based differences. For instance, Took in 2010 investigated the effect of web-based page symmetry by taking gender differences into account. A total of 60 people, 30 male, 30 female, participated in a lab experiment where 20 website start pages had to be rated regarding symmetry, intuitive beauty, classical and expressive aesthetics. Results showed that vertical symmetry is an important factor in an aesthetic website design. it has an impact on intuitive, straightforward beauty appraisals and on classical and expressive aesthetic judgments. Asymmetrically designed web pages were considered to be less beautiful and achieve lower scores on the classical and expressive dimensions. Moreover, the study indicates that the symmetry effect only occurs among male participants. Only men react unfavourably to asymmetrically designed websites, whereas women's judgments are not influenced by symmetry. These findings should be taken into consideration by website designers, especially when they aim to design for target audiences consisting of a majority of a certain gender. When designing technological interfaces, it is important to consider the physical environment the user is operating in, e.g. lighting. How will that affect the colour on the screen, etc.? How the person is interacting with the technology, e.g. via a mouse, or how else are they inputting into, e.g. primary means such as a keyboard, automatic speech recognition. It is important to consider how the person is interacting with the technology, importance of the relationship between domain and the application, and there are ways of doing this. They include functional. Controls and displays are organised so that they are functionally related and are placed together. Sequential. The controls and displays are organised to reflect the order of their use in a typical interaction. And frequency. The controls and displays are organised according to how frequently they are used, or the most commonly used control being the most accessible. Now, the entire system must be arranged appropriately in relation to the user's position. This is important for things such as menus, where the controls need to flow in a logical manner so that people can select what they want in an appropriate way. One example of how this is done is the Unix system, which is characterized by modular design. This is sometimes called the Unix philosophy. This concept entails that the operating system provides a set of simple tools that each perform a limited, well-defined function. Raymond, 2003. Dividing the system into smaller parts, as is the case in modular design, makes it more simple, which makes it easier to use. The Unix philosophy emphasizes building simple, short, clear, modular, and extensible code that can be easily maintained and repurposed by developers other than its creators. It often can be the case that people can bypass going through menus and instead can express instructions to the computer directly, although an issue can be knowing these means of bypassing, which can involve a requirement for memorization, which means that people require an element of expertise in order to utilize this function. Key to the input style is also the QWERTY keyboard. This is based in the particular letter formulation it is, due to it being a representation of the typewriter. This makes sense, as people transferring from using a typewriter would be used to inputting letters with pressing keys in those particular places, therefore the transition would be appropriate. One interface that is used on many interactive computer systems is the WIMP interface. In a WIMP system, in human-computer interaction, WIMP stands for Windows, Icons, Menu, Pointer, Hinckley 2011. A window runs a self-contained program, isolated from other programs that, if in a multi-program operating system, run at the same time in other windows. An icon acts as a shortcut to an action of the computer programs, e.g. to execute a program or task. A menu is a text or icon-based selection system that selects and executes programs or tasks. And the pointer is an on-screen symbol that represents movement of a physical device that the user controls to select icon, data elements, etc. This style of system improves human-computer interaction by emulating real-world interactions and providing better ease of use for non-technical people. Users can carry skill at a standardized interface from one application to another. However, there has been a push in the industry to move past the traditional WIMP interface to instead focus on more reality-based interaction. Jacob et al., 2008. One popular approach to redesigning the WIMP interface is to use a three-dimensional interaction, including consideration of visual depth in the interface. Nirmal and Mishra, 2013. Agarwala and Balakrishnan in 2006 ran qualitative studies asking bump-top users, i.e. users of an operating system that includes physics and visual depth that were commercially acquired by Google in 2010, to share the subjective views concerning the interface. Results suggest that some positives of the system, however, did not consider the cognitive mechanisms related to target detection. There are others that suggest that adding a layer of interaction increases complexity, which in turn has a negative impact on user efficiency. Cockburn, 2004. A limitation of these studies is that they built a 3D interface and then used qualitative, subjective measures to explore whether the users enjoyed the new interface over the traditional WIMP interface, or measured the total time taken to find an icon, a reasonable metric of efficacy for target selection, without controlling for possible confounding variables. For example, by not providing incremental layers of visible depth, the research failed to consider whether increasing the quality of distractors resulted in users taking longer to find a target in these environments, or whether it was due to the novelty of using a 2D mouse in a 3D space. Indeed, individual features and their conjunctions have been shown to bias attention focus in ways that influence target detection efficiency. Wolf, 2013. It is on this basis that Critici et al. In 2016 aim to operate when they complete two experiments, where one large sample web-based experiment to understand associations and one controlled lab environments using eye tracking to understand user focus. They investigated how visual depth, use of visual aids, use of semantic categories, and lower-level stimuli features impact how successfully participants are able to search for and detect the target image. In the lab experiments, they captured pulmonary measurements to allow consideration of the influence of increasing cognitive load as a result of either an increasing number of items on the screen or due to the inclusion of visual depth. Their findings showed that increasing the visual levels of depth and inclusion of converging lines did not impact target detection times, errors, or failure rates. Low-level features including color, luminance, and number of edges did correlate with differences in target detection times, errors, and failure rates. The results also revealed that semantic sorting algorithms significantly decreased target detection times, increased semantic contrast between a target and its neighbors correlated with an increase in detection errors. Finally, pupillometric data did not provide evidence of any correlation between the number of visible layers of depth and pupil size. However, using structural equation modeling, they demonstrated that cognitive load does influence detection failure rates when there is luminance contrast between the target and its surrounding neighbors. The results suggest that the WIMP interaction designs should consider stimulus-driven factors, which were shown to increase the efficiency with which a target icon can be found in a 3D WIMP interface. Another key element to the design of interfaces is interactivity, which essentially refers to the dynamics, the way the system reacts to a user's actions. Cognitive ergonomics is key to this, and is concerned with how well users understand the system, how capable is the system in allowing the user to do what they want. The development of design models of the system and acquiring semantic and procedural knowledge of the system's functions, limitations, and desired outcomes. A key way of understanding this is through the execution evaluation cycle, Norman 1982 in Dix et al. 2004. In this, users formulate plans of actions, and they are executed at a computer interface, and then the user observes the computer interface and evaluates the result, and then the next action is determined. The execution and evaluation comprises 7 stages: establishing the goal, forming the intention, specifying the action sequence, executing the action, perceiving the system state, interpreting the system state, and evaluating the system state with respect to goals and intentions. There are critiques, though, of Norman's model. The goal of execution and evaluation, a useful means of understanding interaction, consists of systems only insofar as the interface, and concentrates wholly on the user's view, does not, though, attempt to deal with the system's communication through the interface. One way of understanding the mental activities required for an ergonomics task is through the framework like GOMS. By identifying the sequence of mental activities of a user engaged in a task, cognitive ergonomic engineers can identify bottlenecks and critical paths that may present opportunities for improvements or risks, such as human errors, that merit changes in training or system behavior. Wilson, 2013. One criticism that can be made of the field of human-computer interaction is the focus on humans as though they are one heterogeneous group, where particular advances in computer design will be beneficial for all humans. The reality is that humans are varied, and individual differences is a key element of psychological study. Therefore, it is appropriate for a focus to be placed on individual differences in the field of human-computer interaction study. This is an area in which research has been developing, particularly that by large industrial giants such as Microsoft, with a particular focus being applied to those with disabilities. For instance, Morrison et al. In 2018 considered how to make the process of learning computer programming more accessible for 7 to 11-year-olds with visual difficulties. To achieve this, they created Torino, which involves using tangible beads, which when threaded together represent the same thread that would occur in an execution model on a program. This was found to aid the children who were tested in their understanding of programming, but also having a benefit of being a process which all children can use, regardless of their level of vision. This notion of trying to make computers accessible for those with visual impairments, but not to do so in a way which segregates them from others who don't have those impairments, is particularly important. It also provides justification for the study by Bennett et al. In 2018, which looked at how teens with visual impairments access smartphone photography from the time that they take photos through editing and sharing them on social media. They observed that teens largely wanted to engage with photos visually, similarly to their sighted peers, and have developed strategies around photo capture, editing, sharing, and consumption that attempt to mitigate usability limitations of current photography and social media apps. Based on the investigation, design recommendations were made which are focused on changing the technology itself as opposed to those with visual impairments having to seek alternative technology. For instance, Instagram allowing a user to zoom while editing a photo was a suggested improvement, which could make a difference to those with visual impairments, and should not negatively impact upon those without. Also, the suggestion of an individual being able to apply filters onto pictures which appear on social media so that they can view other pictures more easily. In addition, the paper points out the Lumina Selfie app, which makes a beep sound so people know when they are center frame, which is a built-in enhancement that people can choose to use or not, and could be something that all may use, including those without visual impairments. Research has also focused on those with dyslexia, with Forney et al. In 2018 investigating what factors were associated with readability and relevance. They found average number of characters that fit on each line of text, average image size in pixels, ratio of text appearing in sentences versus not in sentences, e.g. titles and labels, to be associated with readability and relevance for both groups, and therefore suggesting that factoring in these elements could help the overall population, as well as having a beneficial impact for the cognitive accessibility of web-based materials for those with dyslexia. There are other things that need to be considered when designing such interfaces. But in terms of assessing the effectiveness of these interface changes that come about from our designs, there are certain things that can be done. For instance, there is a 4 steps component framework. The Interaction Framework by Dix et al. In 1993 has 4 components: the system, user, input, and output. There are 4 steps in the interactive cycle. The user formulates a goal and task to achieve goal. The task is articulated within the input language. This is articulation. Then the system transforms itself according to operation translated in the input. This is performance. The system is now in a new state which is communicated to user as concepts as features through the output, presentation. And the user observes output and assesses the interaction relative to the original goal. That's observation. A means of judging the overall usability of an entire interactive system can be achieved with this cycle. Prototyping and navigation design can also be a critical part of this. Prototyping is a hill climbing approach. You start somewhere, evaluate it to see how to make it better, and then keep on doing this until it can't get any better to be successful. With prototyping, it is critical to have a good starting point and to understand what is wrong and how to improve. With navigation design, you need to be able to understand what will happen when a button is pressed to understand where you are in the interaction. In this, there are 2 types of structure: a local structure, which would be, for instance, a single screen, and global structure, which would be a whole site. For goal seeking on a local structure, you can progress with local knowledge only in order to get the goal as efficiently as possible. It is suggested by Dix 2004 to use 4 golden rules of knowing where you are. This can be achieved through having a website hierarchy which sections the website to establish where exactly you are in the grand scheme, knowing what you can do, knowing where you are going or what will happen, and knowing where you've been or what you've done. Global structures look at between screens and within applications. Hierarchical diagrams can help with this. This can help split functions. However, how to navigate between these functions needs to be considered. If it is deep, it may be difficult to move through hierarchies. Network diagrams can be used to show different paths through systems. They show what leads to what and what happens where. These will also include branches. They are also more task-orientated than hierarchical diagrams. And there is summative and formative evaluation as ways of gathering appropriate holistic feedback on the effectiveness of the system. Reason, in 1999, defined an error as a generic term to encompass all those occasions in which a planned sequence of mental or physical activities fails to achieve its intended outcome, and when those failures cannot be attributed to some chance agency. When an accident occurs, it is often the case that the accident investigation will occur. This investigation will seek to understand what caused the accident to occur and from this perspective shall be influenced by considerations of what role human error played in the development of the accident and what role organisational factors played in the role of the accident. This essay shall consider the causation of accident models which form the premise of attributing blame to either human error or organisational factors, and explain how these theories place blame on such factors. Once an understanding of these models alongside an appreciation of the theoretical soundness of these models has been established, this essay shall then use the examples of real-world accidents in order to establish how well these models apply. One model which emphasises the role of human error is the model proposed by Heinrich in 1931 called domino theory, which states that a linear sequence of events leads to an accident or injury. It says that hereditary and social factors lead to the fault of the person, which was a proximal reason for unsafe acts or condition, which results in an accident, which leads to injury. Removal of the first four stages is said to prevent injury. However, this is a model for which there is clear criticism. It is arguably quite reductionist, as it seeks to break accidents down to be simply explained, when in reality they have multiple causes. Also, what is meant by the conceptualization of injury is also difficult to pin down, and thus the applicability of the model becomes somewhat limited. Also, the focus on individuals perhaps being unsafe individuals, which is an implication formed by the model, is concerning, as it encourages removing certain workers as the way to remove accidents. This is both ethically problematic and not grounded in empiricism. An alternative model, which also places a focus on human error, is Norman's Execution Evaluation Model 2002. This model distinguishes between slips and mistakes. Slips can result from errors in the formulation of intents to act, faulty triggering of schemas, or mental images of the phenomenal. Slips are action errors, e.g. striking the wrong key on a keyboard, pouring coffee into a cereal bowl instead of the mug next to it, speaking a word other than the one intended. Mistakes are errors of thought, in which a person's cognitive activities lead to actions or decisions that are contrary to what was intended. The model also suggests that a gulf of execution can evolve when a user is having difficulties to determine how to execute a goal. Also, there can be a gulf of evaluation, as users have trouble assessing the state of the system. Other models, rather than just placing a focus for error upon an individual, instead focus on how organisational factors are also relevant. These models, such as the systems approach by Reason in 1995 or the Swiss cheese model by Reason in 1997, emphasises the notion that for an accident to occur there are several problems that need to occur, and that essentially an accident should not occur because the several layers of defences that are in front of it. However, there can be gaps in these defences, and if all these gaps align, then the accident can occur. The Swiss cheese model also makes a distinction between active and latent failures. Active failures are deliberate acts or behaviours, immediate adverse effects on system integrity, committed by those directly involved in completing work tasks, and directly circumvention of systems defences. Latent failures, meanwhile, are decisions or actions where effects lie dormant. They are evident when combined with local triggers present in the system. They are likely to arise from activities removed from person-machine interference well before onset of recognisable accidental sequence. With latent failures in particular, it could be argued that a failure could lie dormant within the system for a long time, only becoming evident when they combine with other factors to breach the system's defences. Reason argued that the likelihood of accident is related to the total number of problems in the system and their interaction with local triggers. It is argued that in a more advanced system there is the opportunity for more dormant problems, but in more simple systems it takes fewer problems to breach the defences and cause an accident. Reason also argues, based on the model, that the higher the person's position in the organisation, the greater the opportunity they have to create dormant problems. It is also argued that it is impossible to foresee all local triggers, but dormant problems should be identifiable. There is an emphasis that an emphasis should be on designing out or identifying dormant problems and not focusing on local triggers. It is also argued that short-term breaches may be created by the errors and violations of frontline operators, but that longer-lasting and more dangerous gaps are created by the decisions of designers, builders, procedure writers, top-level managers and maintainers. Clearly in this model, the role of organisational factors is considered to be critically important. There are clear criticisms though. Luchot and Kaufeld in 2003 writes that one of the disadvantages of the reason model is that it does not account for the detailed interrelationships among causal factors. Without these distinct linkages, the results are too vague to be of significant practical use. Decker in 2002 argues that the layers of defence are not static or constant, and not independent of each other either. They can interact, support, or erode one another. The Swiss cheese analogy is useful to think about the complexity of failure, and conversely about the effort it takes to make and keep a system safe. It can also help structure your search for distal contributors to the mishap, but the analogy itself does not explain where the holes are, or what they consist of, why the holes are there in the first place, why the holes change over time, both in size and location, and how the holes get to line up to produce an accident. And it is up to you, the investigator, to find out for your individual accident situation. Finally, Chappell and Wiegmann in 2000 note that, in many ways, Reason's Swiss cheese model of accident causation has revolutionised common views of accident causation. Unfortunately, however, it is simply a theory with few details on how to apply to a real-world setting. In other words, the theory never defines what the holes in the cheese really are, at least within the context of everyday operations. Schrock et al. In 2005 says that the extensive focus on latent failures means that active failures are not given due attention, and that clear human errors and indeed what factors can influence them are not given appropriate attention. It is also argued that it is only possible with hindsight to see a link between some latent conditions and an accident, and that the link more generally is tenuous. Reason does attempt to directly address these criticisms, as in newer versions of the model, a focus is less on managerial failures but rather on organisational features. It is accepted that a frontline operator slips can sometimes fully account for an accident. However, it is argued that from a safety management perspective, there is still an appropriate strategy available, which is of fixing the operator. From an academic perspective, the weakness of the Swiss cheese model is that it is irrefutable by standard scientific methods, making it hard to evaluate. This means it is only through applying it to real-world accidents that credibility can be evaluated. These models insinuate the role of human errors and organisational factors in accident causation. However, as systems grow in complexity, it can be argued that newer models need to be developed to be applied to increasingly complex technology, which can form the basis of accidents. This is particularly so as maintaining safety with complex systems is difficult and can lead to costly consequences. Struak in 2017. In the proposed model by Struak, an event which could refer to an accident is preceded by an antecedent and an error. The antecedent will be the company, the equipment that may be used, etc. With an action or a decision, if this action or decision is an error, it will lead to an event which could be an accident, which could cause an injury. This model therefore focuses both on how organisational factors which can influence elements such as having appropriate equipment and on individuals influencing the error. However, of critical importance in the model is establishing a relationship between antecedent and error. This process is largely inferential and based on investigative logic, understanding the nature of the error and what leads to what. A key question is, would the operator have committed the error if this and other antecedents had not preceded it? From this, statistical techniques can be used to determine the relationship between antecedents and errors. The relationship between antecedents and errors should meet three criteria. They should be simple, logical, and superior to other potential relationships among variables. This process should aim to establish as little or as many antecedents as possible, and key to this is continuing until what Rasmussen et al. In 1994 termed the stopping point has been reached. This is the point in which investigators can no longer identify antecedents that can serve as the target for remedial action. This model highlights the varying role that organisational and human factors can have on an accident. In order to best understand how these models apply to real-world instances should be considered. One such incident was when an incorrectly installed fuse in London was cited as the cause of a power failure which left thousands of commuters stranded. Daily Telegraph, 2003. National Grid Transco, the organisation involved, blamed the incident on human error. The accident report stated that the fuse installed by subcontractors 2 years prior had been too small to handle a power surge that occurred when another part of its transmission network failed. In this scenario, it was employees who made a mistake which caused the accident. It could be argued as if they had installed the correct fuse, it would not have occurred. The exact reason why this error was made is difficult to tell. It is likely due to individual factors as they themselves did it, however the exact nature of why they did it is hard to ascertain. There may also be organisational factors. If the organisation prioritises rushing an operation, it may cause the workers for the contractor to be under pressure, which causes the issue to occur. There is also evidence from this from the Swiss cheese model. In this accident, two things occurred which should not: the power surge and the incorrect fuse. These two mistakes in isolation did not cause the accident, but when combined they created the error. There are examples of antecedents combining to create an accident, but also how there were two holes in differing parts of the process which are supposed to stop these sorts of errors occurring. Detailed investigation of the above incident led to the conclusion that it was a contractor error, but since there was an error lying in wait, a latent failure for 2 years before it revealed itself, it was impossible to ascertain what sort of failure it was: error, violation, slip, lapse or mistake, let alone the underlying cause. One important point from the report to highlight is that it stated, "The rating of the automatic protection equipment that is included on the documentation used for commissioning could have been more clearly visible to the commissioning engineers." In other words, there was a problem in the documentation/procedures used. This simple problem surely then has a simple solution: correct the documentation to improve the information provided. Clearly there are therefore organisational factors at play in this incident, despite National Grid Transco's enthusiasm for placing the blame on human error. Another incident was the Alton Towers Smiler Ride crash, where 2 women had legs amputated after the Smiler Ride hit an empty carriage. BBC, 2015. The following investigation established that the crash was due to staff misunderstanding a shutdown message and wrongly restarting the ride. The investigation found that no technical or mechanical issues were found with the ride itself. Instead, the misunderstanding of the message by staff led them to decide to manually restart the ride, overriding the control system without appropriate safety protocols being followed correctly. Therefore, the proper process was said to be in place. However, it was the case that staff did not follow these proper processes. This is therefore due to individual factors, as this clearly follows the framework for human error, with the staff completing an intended action under false pretenses, meaning they made a knowledge-based mistake. Although it could also be argued that if staff was said to misunderstand the shutdown message, then this could be due to organisational factors such as poor training, and that poor training is a latent failure which became apparent in the response of staff members. It is, however, difficult to fully understand the cause of this accident and the role that the organisation of Alton Towers played in it, as the report was not publicly released, meaning the only information we have access to is that which Alton Towers themselves provide. Another example of an incident is the Tokimura criticality accident of 1999. In this incident, 3 workers with no proper qualification and training requirements were preparing a small batch of fuel for an experimental fast breeder reactor using a much more enriched uranium for the first time. This eventually caused the nuclear fission chain reaction to become self-sustaining and began to emit intense gamma and neutron radiation, triggering alarms. Although there was no explosion, the criticality lasted intermittently for about 20 hours. Opus Kinetic, 2017. According to the investigation, the accident seemed to have resulted primarily from human error and serious breaches of safety principles, which together led to a criticality event. The organisation, the Japan Nuclear Fuel Conversion Co., had permission to complete a fuel preparation procedure. However, they modified the procedure without permission from the regulatory authorities. By doing this, they increased the likelihood of criticality. This shows how the interaction between organisational and individual factors is important and can be an influence that changes the likelihood of an accident occurring. The investigation did, however, also note that the state regulator had visited the plants only twice per year, and never when it was operating, suggesting that this was another non-individual or organisational factor which was responsible, suggesting how an even wider variety of factors are important that go beyond what some of the accident causation models suggest. In conclusion, there are many models on accident causation which suggest a varying role for organisational and individual factors. An issue, though, is that these models can be difficult to empirically test, and thus the appropriate means of testing them comes through applying them to real-world accident investigations. These investigations generally present a picture that both of these factors are involved, and that actually the interaction between these factors is important. However, a problem with gaining information from these investigations is that it is often the case that organisations can be reluctant to release complete information, meaning we are often presented with a biased view, keen to present human error as the main cause. In order to fully understand the role of different types of factors, we need to be more considerate of the role the two have on influencing each other. But also, we need to have access to more information from accident investigations, so that it can be investigated in a more scientific and open manner. In order to achieve this, it is imperative that we put pressure on lawmakers to allow such information to more easily enter the academic domain.